guys, welcome back to Rocket Gyan, my fellow space tubers. How are you all? And finally, welcome to the live stream of the launch of the Astra Rocket 3.3. And why this launch is special? Well, you will get to know about it. So hi everyone, welcome to the stream, and you don't need to worry about anything because everything will be covered here, about the rocket company, about the rocket, the payloads and everything. So just sit back and relax and enjoy the live stream. So hi everyone, hi Louis Smith, hi Roblox, hi Twin. T-0 is 1 p.m. No, it's I think 2:10 okay, 1 p.m. CT. Okay, then fine, it's 2 p.m. Pacific. So hi everyone, hi Manny, hi Repure, and hopefully everyone is doing great. So let's just have a look at what this Astra company is all about, right? And can you just write me in the chat where my voice is all right and everything is perfectly fine? If you can, it would be great. Okay, so this is a satellite launch means the rocket launch company, and what they are doing is, yeah, so what they are doing is they are first of all, they used to launch from Kodiak, Alaska, which is right here. So you can see Alaska, they were used to launch from there, and now for the first time they will be launching their rocket from Cape Canaveral. And this is one of their strengths, you can say, because their rocket is so small that it can be easily carried in a truck, even in a mountainous region like Alaska. So because of that, they can the rocket can be carried anywhere, and and that's why the kind of, you can say, opposite corners of US, it is being launched today. So it will be launching from Cape Canaveral today. So regarding the aspects about this launcher, I would say they can send up to 500 kilograms to mid inclination, 335 to solar sun synchronous orbit, which is like a polar orbit, which is, as the name suggests, sun synchronous orbit is a orbit in which you are synced with the sun. You means you always face the sun. That's what meant to say. And 630 kilograms to low earth orbit. Right now this is not the capacity, this is their, you can say, the full capacity they want to go. Right now they have just like 225 kilograms to 100 kilograms. That's all they have right now. And yeah, the fairing and is a larger one, and which can host multiple payloads, which is being demonstrated today for the first time again. So this is the the rough idea about the company. Now let's have a look at their launcher in detail. Okay, so this is their launcher. If you can have a look at it, I'll just, so here you go. So this is a Astra 3.3 rocket, as they say. And here, if I can, so here, this is the first stage. There you go. This is the first stage and this is the second stage. So there are two stages in the rocket, and the first stage is powered by 5 Delphin engines. So these Delphin engines are electric pump fed, which means they, the turbo pump is not mechanical, but the motor, or you can say the pump, is controlled by the software, and it is run by battery and not any pre-burners kind of a thing. So this is a cool pump, because the electric pump fed engines are relatively easy to make and are less complex. But again, the downside is that you need to have batteries also attached with it, which takes up your payload capacity. So yeah, that is the case. And that's the reason why it makes sense. The electric pump engines make sense in a small sat launcher like this. So this is a 5 Delphin engine running on RP1 and LOX as its fuel. So they are using cryogenic fuel. That's one thing. And then this is their second stage, which is actually enclosed in this fairing. And this second stage, as you can see from the looks of it, it's like a skeletal second stage. It's not like a, a proper second stage, like just like the first stage. No, just a skeletal one, because the second stage is just a pressure fed engine, and they literally want to cut the amount of weight on the second stage so that they can increase the amount of the payload capacity which it can carry. And that's why they just went for the skeletal one, because you don't need that complex structure of it, because this is just a pressure fed engine, which means no turbo pump, nothing, just a pressure fed engine. Means that tanks are highly pressurized, and then the valves are opened, and the 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 fuel ignites. So again, this also runs on RP1 and LOX. So this is how the rocket looks like. And I can just, yeah. So this is an overview of the rocket. Now let's have a look at the payloads and everything. uh Wait a sec. Oh, so this time today, they will be launching a initiative from NASA. NASA is the customer today, and they have this CubeSat launch initiative. So this CubeSat launch initiative is basically, you can say it is empowering students and basically colleges, universities, and schools to make satellites, to make CubeSats, to basically make something for space, so that you can get, you know uh, develop that interest in space. So this is that initiative in which NASA kind of funds the funds and provide mentorship to the universities to do some research on this. And what NASA gives is that it provides free ride of your satellite to space. So the paying customer is NASA, but there are three CubeSats from universities and one CubeSat from NASA itself. So this is the ELaNa 41 mission, as they say, for this. So now let's have a look at the first satellite which is going, and they are very interesting one. So this one is the known as the Bama 1, made by University of Alabama. This is a 3U CubeSat weighing 2.5 kilograms, and it is a technology demonstration satellite, which is to demonstrate the effectiveness of drag sail on a CubeSat. So right now, the CubeSats which are launching in space, they don't have a propulsion system, and because of that, when they, when their life is over, so basically they are a potential space debris, in space junk, you can say. And if you don't have a propulsion system, so you can't deorbit, and you just have to rely on the atmospheric drag, which is natural, to deorbit your satellite, which can take up to 5 years or so. So till, up to 5 years, so it's a long time. So the space junk is just being dumped into space. The space, those satellites are being just dumped into space without even having some propulsion system or something, some management of the garbage after their life is over. So this satellite is trying to improve that situation. How is that? So if you see, they have this drag sail. This is their 1.5 meter, I guess, 1 meter square drag sail, which is made out of clear mylar to drastically reduce the time to deorbit a satellite. So this is the sail which is on the aft side of the satellite. If I can show you that also, here you can see, this is how it is, how it looks like when it is all packed. So this is a very low cost solution for the satellites to just manage their satellites when their life is over. You don't need a propulsion system, because ion propulsion system, or there is a steam propulsion system also coming in market. But right now, the most economic is this one only. Just deploy a sail when your life is over, and this will ensure that your satellite will deorbit in just 2 to 3 months, which will, if it is, if a satellite does not have a sail, it will take around 5 years. This is a very cool satellite being launched today. The other one is this satellite, which is known as INCAV, stands for the ionospheric uh, neutron content analyzer, which is a 3U CubeSat with a directional silicon photomultiplier. Basically, this is the first satellite in low Earth orbit with a neutron detector. Okay, and the goal of this satellite is to gather data on the neutron spectrum in low Earth orbit to improve the space weather models and forecast, as current data is limited to high altitude balloons. So this satellite basically is going to improve that space weather system, because right now what you if you want to do some analysis on space weather, you kind of launch the high altitude balloons with all those instruments. But this satellite tends to improve that by becoming the first satellite with a neutron detector, which is a very cool thing. And yes, so this is that. Now the next one is this one. This is also a cube. This is known as the CubeSat. Yes, QUBESAT. This is a CubeSat, 2U CubeSat on the ELaNa 41 mission. It is a technology demonstration mission, again with the primary goal to test, qualify, and to see what effects low Earth orbit has on quantum gyroscope. So this quantum gyroscope is very interesting. See, we have gyroscopes. If you have seen gyroscopes, it's a very bulkish instrument, kind of, you can say. And they basically they you need a hardware, right? A proper hardware for a gyroscope to work, and gyroscope are very necessary in space to determine the orientation and all those things. So you need a gyroscope. But what if you can have a gyroscope, but it's a quantum gyroscope, which means it's a gyroscope which is inside the atoms. It's a very cool concept, right? So how does it work is, it is a it uses nitrogen vacancy centers in diamonds. So nitrogen vacancy centers in diamonds are point defects where a carbon atom is substituted by a nitrogen atom with another neighboring carbon missing in the structure of a diamond. This nitrogen vacancy center has measurable quantum properties, which makes it possible to form a gyroscope that measures angular momentum. So you are literally, you can say you are sending a piece of diamond with some nitrogen defects, and you are just measuring those nitrogen vacancy centers to determine the angular momentum of the satellite. How cool is that? You are you are not actually having in a hardware, but you are measuring the orientation, or you are making a gyroscope using the quantum properties of the diamond. Okay, the next one, this is the last satellite, which is the 3U CubeSat on ELaNa, and this is developed by NASA. Its purpose is to demonstrate and validate fast and cost-effective services to build CubeSats. It tries to demonstrate key technologies for in-space inspection, which could further help to improve safety on crewed space exploration. So it has high performance computers, cameras, software, and new communication methods. So it's again a technology demonstration, or you can say a prototype for NASA, which is being sent into space. Once this is verified, then they can go on in making a proper solution out of it. So this is how the things look like. And now we can have a look at where is it going, right? So this is going at an inclination of 41 degrees at 500 kilometer altitude. And let me just see if we have the live stream. I'll switch over to that if we already have one. Okay, we still have some worries with. So this is the going to 41 degree inclination orbit, which means it's 41 degrees, which means neither on the equatorial side nor in the polar sides, like it will lie in between. And altitude of 500 kilometers, which means the payload capacity, or we mean the weight which it is carrying, would be very less, because again the payload capacity for this rocket is very less right now, 25 to 100 kilograms. So that is that up to 50 kilograms. I would say. So 50 kilograms with will be the total weight of the payload, and this is going to 41 degrees inclination, and this is how the mission timeline would look like. So as you know, Astra is famous for that, for their X maneuver, which they showcased us on their first live stream. But again, hats off to their TVC you know team, which made such a good thrust vector control that the rocket actually recovered from that aggressive pitching because of some malfunction. So it will begin pitch over. It should have begun pitch over at 6 seconds, but it did during the first live stream. It started pitching over at t plus 0 seconds. So yeah, 1 minute 10 seconds it will achieve max Q. 2 minute 50 seconds main engine cutoff, MECO. 255 fairing separation, stage separation at 3, and 305 upper stage ignition. So this is their thing, and then finally at 8:30 they will cut off their engine. So again, this is a multiple payloads it is going to carry, but you can see there is no second engine burn. Second burn means upper engine second burn, because right now they don't have the capacity or capability, I should say. So whatever orbit it is going to, you can say like 41 degree 500 kilometer, that is the orbit for all of the satellites. There is no as such maneuvering for different orbits or different satellites. That is still a way to go for Astra. Okay, so we have already discussed about the launch vehicle. This overall length, if you want to see, it's 52-inch diameter and 43 feet in height. So it's not a very long rocket, and that's why it can just be transported in a shipping container, as they say. That's the USP of this rocket, as they say. Okay, so now let's have a look at the weather. How's the weather looking? So right now, as per the latest predictions, we have 30% probability of violating weather condition, which means 70% go for the launch. Right now it's kind of windy in Cape, and probability of light rain, so fingers crossed on having a good mission today. Okay, so hi everyone, if you have any questions you can ask me. What is so special about this launch? So this is launch is, let me just first of all move on. So this launch is why is it special? Because first of all, Astra is a very new company in business, and this is launching its first rocket from Cape Canaveral. As I said, they don't launch from Cape Canaveral, they launch from Alaska, Kodiak in Alaska, which is like two different locations, which is wide apart from each other, far away from each other. And that is one thing. Other thing is that today is the first time they will be launching multiple payloads. So this is also one thing to be looked out. 4 payloads will be launched today, and they will be stacked onto the rocket. And as you can see from the structure itself, the rocket fairing, the second stage is enclosed inside the rocket fairing, and as I showed you, the second stage is a skeletal stage. So they tried to save as much as weight possible in the second stage, because obviously they can't save the weight on the first stage, because it has to be robust. It's going to the atmospheric and giving the max Q, and there's no protection on it, so it has to be protected properly. So yeah, that is the thing. Now I can take questions if you have any, and we can wait for the stream to come in. We'll have like 5 minutes. 5 years in Leo, centuries for high orbits. Exactly. And that drag sail is the coolest mission which is going today, I must say. And let me just tell you that mission is being done by a university and not NASA. So that itself is a very great thing. Okay. this is the first Astra's commercial launch. Actually, I wouldn't say that, because they have launched previously also, and their mission, previous missions had the customer's payload on it, like the defense payload. But again, they were the customers only, so they were paying for that. So you can say this is their first commercial payload, in the sense when they won something, or they actually sold something, because the defense payloads were like those payloads were reserved, because defense they funded the development of the rocket, so they wanted two launches to be successful with their payload. So kind of you can say that this is their first launch in which the customer is not the defense part. This is the NASA has paid. So yeah. Regarding your Twitter space, I will be conducting a Twitter space session tomorrow at 10:30 IST, wherein we will discuss about how do we grow the culture of space and rocket science. So it would be a very great session, and you just set the reminder there, and you would be notified in Twitter, and just go in through your mobile app, and you will be notified, and just click on that link once you are notified, and you will be in the space. Is launch still a go? I live next to NASA, and it's windy and cloudy, and it looks like it won't happen. So regarding that, as I already showed you the weather conditions, see, it's 30%. Let me just zoom out. There you go. So this is the weather conditions. 30% right now says is a problematic here, but 70% go, and I would say let's hope we have a launch today, because again these launches are, when it comes to Astra, as I have streamed many Astra launches now, and I know that Astra tend to have some sort of last minute hitch, either technical or due to weather. So sometimes they postpone, but again they have a good launch window, so we'll have to wait. Regarding the launch window, let me just tell you the launch window. We will have a launch, then what's the launch window for today? So the launch window is open for 3 hours, and we are already in 1 hour of that launch window, and scheduled for 12:40. Yeah, so it's like when the T-0 is scheduled for 1 hour after the launch window begins. So will still be having like 2 hours if something goes wrong with the weather and all. So yes, kind of cloudy, and it's kind of there are probability of light rain as well, so we'll have to wait and see look like. Okay. Oh wow, one viewer. I think some glitch is there on the YouTube end. There's just one watching the stream. Okay, wow. Okay. Now let's have a look at something else if we can. Let's have a look at the this payloads which are going, if we can have some good enough knowledge about them. I think I've already discussed about it, but let's just discuss about this drag sail experiment which they are going to do, right? So if you don't know, guys, if you are just joining in to this is, if this is your first live stream, let me just tell you one thing, that there is something called atmospheric drag in space. And yes, that's the case. You must be thinking that there is no atmosphere in space, and that is true. That is for sure true. But there are some, free atoms, free oxygen atoms, or nitrogen atoms. They are floating in space. So those are or oxygen molecules, nitrogen molecules from the upper atmosphere. They just escape the Earth's atmospheric, what should I say, atmospheric range of around 100 kilometer Kármán line. That's what we say. And after 100 kilometers, we say there is like minimum atmosphere. That's a Kármán line, because you can kind of say that in US the Kármán line starts at 80 kilometers. All over the world it's at 100 kilometers. So let's say after 100 kilometers you are in space. Fine, that is cool. But again, if you are in space, you are not alone in space. There are some oxygen molecules, nitrogen molecules which are floating in space, and because of them, uh, we get to see some atmospheric drag, even though that is very very less. But we can't ignore its effect, because as I said, when the CubeSat is in the orbit, if it's normally the orbit for a CubeSat is around 500 kilometer, which is going today only. So at that altitudes, the duration, the, or you can say the lifetime of the CubeSat is around 5 years. So if a CubeSat is designed to, let's say, function for 1 year, right? Now what will happen is, since the CubeSat is designed for 1 year, it will die after 1 year, and now that particular CubeSat is just a space junk. Now, CubeSats are a very, very small satellites, and they don't have a propulsion system. There are certain companies coming up with the propulsion system, like ion propulsion system, and which Starlink has, and the steam propulsion system is also coming up. But again, those are the propulsion systems, and kind of very bulky and costly to have for a small CubeSats. Like a CubeSat, you know, the size of the CubeSat is like your shoebox. That's a satellite size, and you don't want any much weight on it. And because of that, you don't mostly companies don't have the propulsion system, and once the lifetime ends, it is space junk. So to remove that, can say, problem, we have this in front of you. This is a drag sail which will deploy from the aft of the satellite. It's just like, you know, just sitting on the aft of the satellite here like this, and it will deploy after the life time of the CubeSat ends. And this is like a 1 meter square drag sail, which will enable more of the oxygen and nitrogen atoms to or you can say molecules to collide with this drag sail, which will eventually increase the surface area, as the surface area is directly proportional to the amount of drag you will experience. It's not the mass, but the surface area. Okay, so if you have like a very heavy thing in space, but the surface area of that is very small, then it will not experience much of drag. But if you have very very lighter, you know, thing in space, but its surface area is huge, uh, with the velocity vector, then it will experience that drag. And this is what it is supposed to do. Will move, the satellite will rotate itself or orient itself to the velocity vector and open its drag sail, so that if when it is moving in that orbit, it is colliding with much of many atoms in space, and hence increasing that friction and all that kinetic energy of the molecules, the collision energy, I would say, the collision energy with the atoms as well as the drag sail will decrease the orbit, and finally it will be able to deorbit in just 2 months rather than years. That is the case. Okay, so now guys, we have a problem here, that they have again increased their time. A second, let me just show you what has happened. We have a new launch time now, so you will have to stay with me for a while now, if I'm not boring you. Okay, open that date to it for you. Okay, we have any. We are, yeah. So we are holding the clock at T minus 1 hour 45 minutes. Stay tuned, as they say. Let, there you go. So the tweet has come out. We are holding the clock at T minus 1 hour 45 minutes. Still don't know whether it was because of the weather or so, but as you can see, the weather is not quite clear at Cape today. It's kind of cloudy, so, and windy too, so we'll have to wait and see. I think the hold is due to the weather and not any range or technical issues, but uh, Astra is famous for delaying their launch because, see, this is a small rocket and it's a new rocket, so you need to be very, very, very much aggressive with its parameters of the launch. You don't have like a big range of error, so yes, those constraints are very strict, and that's why sometimes these holding at 1 hour 45 minutes. We don't know whether what's the new time. Can you go over the payload and the mission again, please? I just came in. I can do that again, but okay. So in the meantime, guys, if you have any questions or so, you can ask me. It can be anything. Okay, it can be about anything. I will answer that. And right now the launch is on hold, so we'll have to wait for the things to happen. Till then we can discuss about the things, or we can just have a look at different rockets and the payloads. And if you are just joining in, guys, on this channel we do live streams of the rocket launches, and as you have already heard about what I just listen to what I do. I basically break down each and everything that you need to know before a launch. So whenever it's a launch, I come up, and you don't need to go anywhere to read about the launch before seeing a launch. You just need to come here on this channel, and everything would be taken care of. And I love to do those scientific missions which happen, like the JWST missions, the IXPE mission which happened, and the DART mission, and all those things, because then I could explain the science, and I love explaining the science. So yes, using vacuum assisted hypergolic fuels, are we okay? Instead, what we can do now, let me just first of all, tell me. Let us um, they have update. No, right now we don't have. Okay, fine. Instead, what we can do, uh, any ideas how it's possible to see Venus at night? Earth is facing away from the sun according to the heliocentric model. Hmm. That's a topic which needs some. I uh, don't have much. You know. I'll have to research about that thing. It's a good question, uh, actually, but I'll have to research about it. But I don't think so. We'll be able to see the Venus if it is behind the sun. But I'll have to, maybe something is happening which I don't know yet, so I'll have to search without first of all. Yeah, right now what we can do is we can just explore different rockets if you want. Okay, so we have many rockets which we can discover. So just tell me a one rocket and we can discover that. Okay, and we can compare or two. Like have the Saturn 1, the Saturn 5, the Soyuz rocket, the SLS, Space Shuttle, Pika, Starhopper, Saturn 5, Starship. And regarding the Starship, Elon actually tweeted one thing out that will be soon having one Starship presentation, as he says, but with a fully stacked Starship. So it's like a whole year since we have seen any Starship activity. So it would be great to have something about Starship coming into light. V2 rocket, Vega rocket, Vostok, Vulcan. We have many. Just name and we should can explore those. Okay. Interesting to see the N1 rocket also. Okay, tell me one rocket as I'm. Let's just explore the N1 rocket maybe. Oops. I don't know what is happening. Oh, Z R7. There you go, a huge N1 rocket, which actually I am very much, whenever I read about this N1 rocket, I get very fascinated. I would say that I really wanted this rocket to fly, but it actually didn't fly. So, uh, properly, it flew, but did not made to the orbit and was finally cancelled. It was a huge and humongous rocket and had a very detailed plans on it. Stages: first stage, second stage, third stage, fourth stage, fifth stage, and then the whole lunar module was supposed to have pairing. It was a very ambitious plan from Russian, but again, they did not have those test facilities to make bigger rocket engines, so that's why it failed. Uh, okay, so yeah, Falcon 9 has been in the news. We can discuss about that also. So this Falcon 9 being in the news, and people say that this Falcon 9 upper stage rocket is going to drastically crash onto the moon. It's in an uncontrollable upper stage. It will go and crash into the moon and maybe hazardous to um, the satellites already in the orbit of the moon, like Chandrayaan orbiter as well as the Lunar Reconnaissance Orbiter from NASA. But that is just a piece of crap. Please don't listen to them, because when Apollo launched, Apollo program, during the Apollo program, all the stages, like if I'm not wrong, it was the transfer stage which was dumped onto, crashed onto the moon. Okay, so this is a thing which you kind of do without any problem. Okay, so that's not a problem here. And it was supposed, or yeah, it is supposed to crash on 7th Feb with the velocity of 2.3 kilometers per second onto the moon. And it will just crash harmlessly without any problem. First of all, it is a depleted upper stage, so is no as such, a drastic rud or something like that. And moon is capable of handling those crashes. It is prone. Moon, why moon has craters? Tell me, why moon has craters? Because all the asteroids, the meteoroids, asteroid, I would say, yeah, in case, all the asteroid collides with the moon every time, every day. Like thousands of asteroids are there, or smaller meteoroids, or whatever, the craters are the result of those collisions, and that happens. and moon is capable of handling that. It's like the moon, it won't be for the moon, it would be just a small dot, and it would be a everyday activity for him because he uh, is collided with many asteroids, meteoroids in on everyday basis. So it's not a big deal for the moon. My survey does not include a positive outcome. I don't know what you're talking about, like the um, the poll which I've made, right? I That's the first option is positive. I don't know what you're talking about. Okay, just to say, what we can do is can maybe we can just have a look at how this thing launches, right? Let's have a look at N1 launch if you are willing to, or the rocket 3.0 launch, 3.3 launch, whatever you want to see. Tell me, because we can launch that also. You want to see N1 launch? Want to see any other rocket launch? Or maybe Starship. Let's just see the Starship launch. Where are Starship? Star Great. Where? What the hell? Where is the Starship? Where is our Starship? Why didn't load? Okay, we to load it. Yeah, wait a sec. Just look at the size of the Starship. And one rocket, New Glenn, is also very huge. Shepard, all are everyday rockets. And see the Astra rocket. It's so small. The Saturn V. How forget it. See the huge F1 engines. Space shuttle. And whoa. Just see this humongous Starship rocket. I mean, um the tower is just completing with its first stage, and then we have the second stage too. Just look at this huge thing. We If we can just have a look at the scale. We are If you are literally standing near the rocket, this is how it will look like. And literally SpaceX is making this thing possible, such a huge thing possible. And they will be crazy part is that they will be catching this huge stage with those chopsticks from the launch tower. How cool is that? Okay, let's just go there and we'll see this launch from bit away so that we'll look at it, right? Think it would be good. Yeah, it. So we launch it. Yeah. X. Whoa. Just look at this thing go. This is the onboard camera for the Starship, and obviously the payload is something, right? This is how it would look like when it will actually have a orbital launch. This is so crazy. Actually, SpaceX makes everyone else looks like you are you are very right. Audio is not there. This is a thing called Rocket Explorer. This is an app available on Steam made by Casper Stan. So if you want, you can actually download this thing and can explore it. We should be moving in for the first stage separation now. And we are in the space basically now. You should be seeing the first stage separation. There you go. And first stage vanished. Now the second stage should start up. There you go. Second stage has the three. I think the number of vacuum engines are increasing, right? It used to be three vacuum engines and three sea level engines. So sure about that, but I think it is. Okay, we have seen this thing. Now let's have a look at other rocket, right? The V2 rocket, the first rocket which actually went, which was launched basically. Uh, Vega, the Vulcan rocket. Vulcan rocket will have those SRBs also, and the power slide of the Atlas 511. If you witnessed that, then that was the last power slide of the Atlas 5 series, because you won't see that happening with Vulcan. Vulcan is a symmetrical rocket with the SRBs kept in mind. It is designed so that SRBs with symmetrical positions can be uh, strapped onto it. So it won't be having those. You won't be seeing those power slide of the Vulcan Atlas rockets. Okay, so now countdown is on hold. Yes, let me just why is my countdown working? Wait a sec. So did that a sec. In the meantime, guys, if you have any questions, you can surely ask me, or we can have a discussion about the things. Let's date it. Hold. Oh, whoa, that was weird. It's on 1 hour left for the window, 1 hour left for the window. Yes, see, we had a hold on 1 hour of T minus 1 hour 45 minutes, and there is a window of 3 hours. So according to that, we should be resuming 1 hour 45 minutes before the 3 hour window uh, launch window closes. So according to that, if it is closing at 30, we'll be having 1:30. We have like, yeah, 1 hour 15 minutes before the stream, before they should pick up the countdown. What else? What is the other rocket you want to see? I want to see how this star hopper will launch. Will it go to see orbit or what? Let's see. Or it will just land here. This was the uh, this is the badass thing, right? Which is still which was launched successfully first, and it still remains, and it is the guide for all other launches. Okay, so it is landing here. It just its pad, it lands. This will have it land on us. Okay, I would have fried by now. It was real. Okay, cool. That's cool. SLS itself is a big rocket. So even it has those modules, also the lunar, the Orion modules. Great. Okay, let's one just. So I have a question about your launch. I live around 65 miles west of Cape Canaveral. Will I be able to see the rocket in the sky from here? 65 miles west of Cape Canaveral. Okay. So it would be 65 miles is huge actually. And it's a very small rocket also. So, and the weather is also not very likely to support the actual viewing. So I would say no, won't be able to see the launch, unfortunately. Let's just load up the Astra rocket only. This rocket looks literally looks like it will fit into the shipping container, and it does fit into the shipping container. This is a very small rocket, but again, the purpose of this rocket is just to have 25 to 150 kilograms right now, but in the future it is aiming for 500 kilograms with more optimizations and more fuel. So we'll have to wait and see. But right now, it's a small rocket launcher. Now we can see if we let me see if we have any other update, because we were supposed to wait. Whenever we have, I'll move that. So, Still, we are holding a T minus 1 hour 45 minutes. It was the latest tweet. And other than that, is there any special thing happening in space you want to discuss about? Because I don't remember or recall anything right now. So, yes, regarding those launches, which actually launched the launches of the SpaceX Falcon 9 for the Starlink, the NROL 87 mission, and before that also there was one launch. The video quality of the SpaceX launches is just increasing dramatically. I just don't know when they will stop giving us the proper footage of those rocket launches with the beautiful separation. If I can even show that, that would be great. If you haven't seen that, you can just go on to my channel also. The first video which you will see, I uploaded the short. You'll be able to see those beautiful views captured by SpaceX Falcon 9. Okay, so I don't know what you are writing in the chat in Russian. So if you know English, you want to ask something, please write in English. I don't know Russian, unfortunately. It's on hold right now. It's not scrubbed yet. So don't lose your hopes. It's on hold. We still have to wait and see how it will look like. Can actually maybe just see this I can actually, just open up KSP and start playing KSP for the time being, because we have to uh, still have some time left and we have to be ready for that. But the problem with my laptop is that it is a very shittiest laptop that I have right now. I have to purchase one. So if I open up KSP now, would just burn down my PC. This talk go to the moon? No, this talk does not go to the moon. The new time, see, it's on hold, so we don't know the new time yet. Okay, so whenever we will be having any update, I'll just switch over to that. I'll just just tell you that. So don't worry about it. Yes, I could just go off the stream and take a break, but I would rather have a discussion with you guys if you have any topic for me to discuss. Uh, Let me just talk about some scientific topic which is very uh, good use and would be very interesting. All okay, there's certain things coming in, but I would like to hear from you guys. If you want to chat about something, just type in the chat. Okay, regarding the human space flight, okay. So, do you know this thing that for the water is basically a very good radiation absorber. Okay, so whenever there is a solar storm, there was this proposal for NASA from NASA that whenever there is a solar storm, and the ISS is in danger at that point of time, then the astronauts can just go into a water shower. they can just shield themselves with with that water. They can just go into the water, whatever you want to say, water shard they can take, so that they can be shielded from the radiation. And this is a concept which you will see in the right now in the space station. That does not happen because obviously that is not possible with such a small amount of water reserves. But this is a one thing which is in consideration for long term missions, like for the Mars mission. For the Mars mission, radiation is the biggest issue for human beings, and for that, you need to have some sort of shielding. So, there are some movies also regarding this in which they have made a spacecraft which had water shielding all around the ship. Okay, so there is like a layer. The ship has two layers, just the metal layer and then the water layer, so that the crew can be protected inside. Because radiation is a thing, you can actually be saved from the solar radiation, but the cosmic radiation is so damn energetic, lethal, that and you don't even know where is it coming from and when it will hit you. So you have to be prepared for that, and radiation is such a big thing which humans have to deal with. They don't have the showers up in the US. I know, that's why, and that's actually a proposal which was when the space station was being assembled. This was a proposal which was made. So that's what I was sharing. Okay. Falcon 1 rocket. Rocket 1. Okay, that was the rocket 1. Would love to see this. Okay, let's just, have a look at the Astra. We can see the Astra launching and then discuss about the thing also.
Eight, seven, six, five, four, three, two, one.
This is a simulation for you guys so that you can actually just visualize how it would look like, and we can talk about something. The hold is lifted. FK Gaming, if it is true, let me just see. We have a launch time, that means we would also have some stream time. Okay, let me just see is lifted or not. Nah, they haven't tweeted anything. So that is one thing. If we have any update from NASA spaceflight, then I must. Nope, nothing in this case. And they are still not live. So the thing which you are seeing on your screen is those five Delphin engines burning to full thrust, running into full thrust with those electric pump fed cycle running on RP1 and LOX as its fuel. Is it 3:30 GMT? Actually, I don't know, man. I don't see any update from anyone. So okay, they are go for the launch. So this was the skeletal system which I was talking about. Yes, so we have a launch time now. It is okay. So we still have like 1 hour 35 minutes. Let me just update it. Fine. So guys, we are T minus 1 hour 35 minutes until the liftoff happens. That's what we have right now. And this is the second stage running, which is a pressure fed engine, which means just nothing, no as such turbo pumps, nothing, just the pressure fed tanks. And the fuels are pressure fed basically. And when the well is open, fuel mix with the igniter and they burn. Yes, yes. So we'll have a live webcast in 30 minutes or so. If you guys want, I can just repeat the payloads and the things which it is carrying today. Because if you are new here and you want me to repeat that, just tell me, okay? How cheap are their rockets? What is the estimated cost per the launch, and how does that compare to the competition? Okay, fine. That's a good question. So right now, Astra rockets are kind of cheap in the sense that the cost per launch for the rocket is $2.5 million. I know this is not cheap, but again, a small rocket, and according to that, it's kind of very cheap because the Electron, the cost per launch of the Electron is around $6 to $7 million per launch. So um, it is cheaper than that, and if it is able to achieve that promised capacity of 500 kilograms and still be in this range of 3 to 4 million dollars, then it would be very cheaper, I must say that. But don't disregard the fact that there are many small set launchers coming up, not even not in in US only. There are small set launchers coming up from all over the world. There are 3 startups from India. There I can remember there are 2 startups from China and things like that. So we can't disregard the fact that they are the only launch providers, small set launch providers. But yes, things are changing and changing rapidly, and and hopefully you will see one Indian startup launching its first rocket in 2022 itself. So let's hope that happens, and that would be great because uh, you know the Indians, how they do things, they achieve things by keeping the cost really 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 low, right? So yes. So guys, where are you watching this stream from? Just write in the chat. Let's just have a good quick poll on that, right? uh, where are you from? Type in the chat. can have a look at, because I can see some Russians here, I can see some Indians here, but what else? Obviously some people are watching from US itself, right? Okay, Central Florida. And how many of you are actually on the launch side? Because that would give us us a good insight, right? If how's the weather there and things like that. So we have people from the moon watching. Okay, Dallas, uh, my mom's basement, Nebraska, Daytona Beach, Seattle. What time today? EST? It's I don't know the EST time, but you can see the T minus counter over the stream. So yeah, Italy, that's great. So what's the temperature there? Is it really really cold in US right now? I live across the river from the Cape. The weather is not good for go. Um, please don't tell me this thing. But right now they go for the launch, and hopefully we should be seeing the launch today. Let's be optimistic about that. West Palm Beach. Okay, cool. People, I know the weather at Cape is not good today, but hopefully let's just have our fingers crossed. We have a good launch today. Germany. Okay. So we have Utah vodka. Okay. Yes, yes, I can understand. And the payload separation confirmed. So it would look like this t there the mission would span to 9 minutes or so, approximately 9 minutes, and the payloads will be in the orbit. This is how it will look like. What are we watching here, Michael? You were watching the simulation of the Astra rocket launch. Okay. So the thing which you were seeing, the some skeletal system, yeah, that was the upper stage of the Astra rocket. So that's what you watched right now. And now we should well look at other things here. Uh, if you, I can see many people have joined now. So let me just quickly repeat what are the things happening. The payloads that are being launched today on this mission. Okay, what about that? I don't know what is going on with this Russian guys. You can just you know speak in English. I would say write in English. That would be great. Mods, please have a look at if everything is going fine. The chat. Okay, fine. Okay, so today the mission, the rocket which will be launching is from Cape, but what they do is they launch from Kodiak, Alaska, and their first live stream. Let's just see their first live stream, which was the most amazing of all, right? The Astra rocket launch, first live stream. And the maneuver which it performed, right? In this, yeah, this one. If you remember this live stream, this was a gold.
7, 6, 5, 4.
It actually was gold. If if you watched this live stream.
One. Mission. 0. First motion. First motion.
See, hats off to their TVC's team that after such a drastic pitch over maneuver at t+0 seconds, it recovered from that thing. When I was watching this live stream, I was like, whoa, dude, I actually didn't believe my eyes. And it just went on and on and on till it, if you have seen this already, just went on till it encountered some things in here. You can see actually they did it deliberately because they wanted the flight data first of all, and also they did not want to, you know, do any significant damage to the launch site or nearby area. So they wanted the rocket to go as far away as possible, and then obviously they didn't had the fuel to make it to the orbit, but they tried. And then now you will see what actually happened. The rocket, see, then the FTS flight termination system counted in. This was their first flight, which was live streamed after their first successful launch. So it was kind of a what should I say? It was a fun live stream. I would say that. A fun live stream. This is what they do, guys. They launch rockets not only to the space but to the x-axis too also, right? This, see their upper stage, a skeletal looking upper stage, and then it goes the orbit. Their mission is to improve the life on Earth from space by becoming the more efficient and affordable launch provider. Okay, we don't have much to see here. In which we need to see the payloads, right? Don't remind me of that. Engineering take care of that. Yes, engineering took care of that. Exactly. The thrust vector control system of that rocket was mind-blowing, and even actually hats off to the engineers who designed the thrust vector control system. But I would say the thrust vector control, you know, whatever you saw at that point of time was a mix of mechanical as well as software, because the TVC team, whatever you just saw was the result of that software algorithm which saved the rocket at that point of time. It was the hardware also, you know, doing its job, but hardware was hardware. The brains was the TVC algorithms, TVC team algorithms, which actually saved the rocket. So it's off to them. So this is the in this today's launch there are 4 payloads which are going to space. The first one is this one, which is a very interesting one because this payload is a university payload first of all, designed by University of Alabama, and the unique thing about this payload is that it's a drag sail payload, which means this is a CubeSat first of all, weighing around 2.5 kilograms, and this is known as the Bama 1 satellite, and its main objective is to deploy its 1 meter square drag sail made out of clear mylar to drastically reduce the time to deorbit. And this mylar thing is actually a thing which you can actually buy on hardware store. It's so cheap. There you can see this is how the things would look like after it deploys in space. This is a drag sail experiment which they were trying to do. and this will drastically reduce their time of deorbiting a satellite without the propulsion system from 5 years to 2 months. So that's great. Now, and this is how it would look like once it is uh, packed inside these, that this thing, this part is the sail and this is the CubeSat. So you can actually just attach it onto any CubeSat and would take care of that space debris thing. The other one is this known as the Inca, which is the first satellite in the low Earth orbit with a neutron detector. So this is made by the University of New Hampshire, and the goal of this mission is to gather data on the neutron spectrum in low Earth orbit, improve the space weather models. So right now they used to launch high altitude balloons for measuring the space weather. So rather than that, why not have this satellite which can do the same job and actually can remain in the orbit? So this is the first satellite with a neutron detector. So the next payload is this one, the CubeSat. Yes, the name is CubeSat, QUBESAT, and the main objective of this to see what effects low Earth orbit has on the quantum gyroscope. So as I said, the gyroscope is a hardware thing, right? And if you have seen the gyroscope, you can visualize it. If you have seen it, then only you can visualize it. You know how big it is, right? And it's a very important thing to have on a satellite because it determines its orientation. So so why not build a gyroscope which is quantum in nature and not actually physical? So this is what this satellite is going to test that. So CubeSat will look into the application of a quantum gyroscope using nitrogen vacancy centers in diamonds. So this is nitrogen vacancy centers in diamonds are point defects where a carbon atom is substituted by a nitrogen atom. If you have learned about this thing in your high school physics, the semiconductors chapter, and having some impurities in the metal which improves the conductivity of the metal, the semiconductor, basically some sort of thing is similar thing is here. In the carbon atom, the diamond is made up of carbon atoms, so um, there are some impurities of nitrogens, you can kind of say that. So nitrogen vacancy centers in diamonds basically, and this nitrogen vacancy center has measurable quantum properties which makes it possible to form a gyroscope that measures angular momentum. So you are literally measuring some quantum properties in a diamond which actually determines your angular momentum and your orientation. Just wow. This is the next satellite, which is the R5S1 by NASA's Johnson Space Center, and this is to demonstrate, this is a prototype satellite basically to demonstrate various things which it wants to test, like high performance computers, cameras, software, and a new communication method which would be useful in further lunar missions, the crewed missions, and whatnot. So this is a thing, it is going to 41-degree inclination at 500 kilometer altitude. So I have repeated what it is going to do 2 times now, and I hope everyone knows what is this mission all about. And guys, just see this photo, just see this image, and by seeing this image, either you visualize a Falcon 9 or a Atlas 5. But now you see this Astra rocket, right? If it was a Falcon 9 and it was a Crew Dragon mission, the crew access arm is somewhere here, right? And now you see the Astra rocket. The size comparison is crazy. There is a Falcon 9 rocket and there is a Astra rocket. I know they are different class of rockets, but again, it's a fun thing because whenever I look at this Cape image, obviously SLC 46 image, I think of Atlas 5 launching or the Falcon 9 launching. But now the This Astra rocket is also launching, and you can't even see on it on the launch pad if you just look at in your first glance. It's so tiny, literally so tiny. So Russians have taken over the chat. I would love to know what the conversation is going on. Nishant, if you can elaborate what is going on here, if you can do that, please tell us. Because they have taken over the chat, that's for sure. And guys, if you can, please write in English so that everyone can understand, and that would be great. Let me see if we have any other update. From Astra. No, nothing. What time is the launch, Natasha? It is T minus 1 hour 15 minutes until the launch. So the webcast would go live at 15 minutes now, and you should see some rocket launch, rocket views out there. So hopefully that happens. The active translation would be very nice. Exactly. Okay. There's nothing else I would want you to know. I think that's it. Move to other. Tell me which rocket you want to explore. I'll make you see that. Oh, there's a bug now. I can't see the second. Rush. It's cloudy and started raining just now. Oh man, not rain. Please. No, rain. Rain, rain, go away. Come on, the day. Please. Now I am remembering that uh, nursery rhyme, right? Apt for this situation. Okay, no other update. And let me just see the weather at Cape. Okay, let's just see the weather at Cape. What? Okay, right now it's cloudy, but Yeah, it is kind of. Right now it is cloudy, but when it will rain, it's already raining. Don't know. Slight chance of rain shower. High. Slight chance of rain shower right now. 10 degrees. A cloudy afternoon at Cape with 16 degrees temperature. Okay, Vasilisa, if I pronounced your name right. Uh, Many people from Russia do not understand English well, but we are looking forward to the launch of the rocket. We believe in it. Thank you for that. The weather, okay, weather is not ideal. I hope it improves. We can just hope. And this weather thing just really sucks, man. Really, really, really sucks. And that's why that Virgin Orbit's plan of launching the rockets from the plane makes so much sense, because they can just, that's a mobile launch pad there. The airplane is the launch pad from the Virgin Orbit, and whenever there's a problem with the weather, they can just move on to a different location. How cool is that? Weather, I don't know when will weather be not a problem for a rocket launch. When will we have that much control on our rocket that we won't uh, be having any problem with the weather? I don't know when will that day come. We are talking about the nuclear propulsion. We are talking about the going to Mars, but nobody is talking about how to solve this weather problem. This is so irritating and annoying when it comes to the rocket launch. But yeah, and I don't know. See, seriously, we don't even have, to my information, we don't even have any startup coming up to solve this issue. See, we rocket nerds who watch this rocket launches are familiar with this problem with the weather and all, but still, it's annoying, man. Annoying. There must be something, at least something, which we can do. I know the weather has some effects on the aerodynamics of the rocket, but again, still, man, airplanes also work, right? There will be something someday, hopefully, that we won't be having any problem with the weather at least. What is the animation? This is the Rocket Explorer from this is a Rocket Explorer basically, and this is the Astra rocket in front of you, and this is the exploded view, the first stage and the second stage above. I just, made this have this in front of you so that you can actually just see this rocket. This is the rocket, how the two-stage rocket of the rocket. The last rocket was delayed 3 times exactly. And that is the problem with the SpaceX, is not known for scrubbing the launches because of the weather. Most of the time, the SpaceX is able to handle, uh, if it is a non-crewed launch, it is able to handle the launches. But last week was, oh man, 3 times in a row it was scrubbed due to weather, and then the wayward ship, a cruise ship, and then finally it launched. But when it launched, dude, it gave such a beautiful views of the rocket. Those ground cams of the SpaceX is so amazing. We were actually saw those beautiful stage separation views from the ground, and it was surreal actually. Yes, Daniel. No launch yet, but we are still at T minus 1 hour 6 minutes. And if it is so, we should be having the webcast starting in just 6 minutes or so. A lot of people in Russia have bought Astra stocks. That is very, very weird. I don't know if it is weird or not, but this is an American company, and Russian people have bought the Astra stocks. It's very shocking for me to see. No, and that's why I can see many Russians in the chat. That is also thrilled to see SpaceX launches every time, but not the same with the Astra. Astra has, again, I'm saying it's a new company, so does not have that amount of data which SpaceX had to increase their margin of error for their rockets, for the aerodynamics of the rocket. So uh, that's why right now, as they launch more and more, their weather constraint will become lenient. We'll have to wait. If you remember, the Falcon 9 actually uh, did one launch in which it actually surpassed the weather conditions for the landing site, and it just they just SpaceX just tested it out whether are the booster can handle that weather conditions, the drone ship, near the drone ship, and it was able to handle it. So they got that new data, and now because of that, they increased their margin of error there. Start soon or we'll sleep. Already night here in Russia. Oh, I don't even have that. Okay, just a sec. Right now, okay, fine. Finally, some music at least. When is it supposed to launch? We should be having four webcast beginning in just 4 minutes. Just wait for 4 minutes, and we should be having the webcast beginning soon. Yeah, wait for some time now. Okay, not 4 minutes, actually 15, 20 minutes until the webcast begins. 30 minus 1 hour 3 minutes until the launch, guys. And if it is so, if the webcast is beginning at 15 minutes delayed, so I think the launch would also be 15-minute delayed. We'll have to wait and see. This is the problem with this. I should have seen the timing. Okay, no worries. This is the weather right now at Cape. Kind of the light showers are predicted, but right now hopefully it's just cloudy. We'll have to wait and see. What should we do? Tell me, guys, because we'll have to wait for some more time. This seriously sucks. I would have played KSP with you guys, but my laptop is not will not support that. If I just open KSP, the stream would go bye bye. I told you, that's what I told you. 20 minutes or so before the webcast begins. Okay, so we have some update from Astra that There, yeah, there you go. Counting down from T minus 1 hour 5 minutes. Live coverage will begin at 11:14 Pacific, 2:45 Eastern. So finally, they are counting down from 1 hour 5 minutes, which means we are go for the launch. That is great. T minus 1 hour 5 minutes, which means my countdown timer is right. Yep, my timer is right. So let's not lose hope. And in 15 minutes or so, webcast will begin, and we should be having some cool views of the rocket. If you have to see the cool views, this is how the rocket would look like. With the NASA logo, this is their fairing, and in here the second stage resides. So it's that. I have already told you about all the payloads going in today. And guys, if you are coming in today and watching this live stream, let me just tell you right now that you can give me a follow on Rocket Gyan at Rocket Gyan on Twitter, and I basically tweet about various things happening in space and all those things. Like this was one of the things which I tweeted out: Apollo 11 landing site imaged by Chandrayaan-2 camera, the high resolution camera. You can see the Eagle descent stage here. These are the things there. I mean, basically all things related to rockets and space. And tomorrow I am actually having one thing, which is this. How I'm planning to do a Twitter space and how can we grow rocket science culture. So if you want, you can actually just join me tomorrow, and on Twitter, and we can have a discussion on that. It would be a great panel. I have actually contacted somebody, and hopefully they will join in. So we'll have a great panel, great insight. If you are interested, you can come and join me. SLS is awesome. Everything space me. Look at what I wrote. SLS is a waste of money. Yet the child. People say that SLS is a waste of money, but I always say that SLS is the need of the hour. Not a waste of. I would rather, make that term to like SLS is the need of the hour rather than waste of money. It is expensive, obviously. $2 billion per launch is way expensive. $2 billion is like the annual budget for various space agencies like ISRO. So it's very expensive, but again, it's a need of the hour. Starship cannot handle those lunar missions yet. So SLS is the way to go. And yes, this did you did you follow this Tonga explosion which happened? Tonga explosion, the volcanic eruption which happened. That was such a huge event that it was even visible from space, and this imagery is captured by us from a satellite, and you can even see the shock wave traveling. And this shock wave actually traveled all around the earth 2 to 3 times. It was such such a high magnitude. If you have watched The Expanse, they did not, I am quoting that reference here, that they did not even have structures. The people living near Tonga did not even have structures to have some shelter into. Okay. And if you haven't watched The Expanse right now, till now, please go and watch it. I'm telling you, you would love it. Okay, so this is one new news here, that the vessel names on SpaceX 2 Dragon recovery ships have been painted over, and now they have been renamed from Go Searcher and Go Navigator to Megan and Shen, the honor of SpaceX first 2 female astronauts. That is great. It is a great news. Yes, it changed. Wow. They have renamed their recovery ships, Dragon recovery ships, from Go Search and Go Navigator to Megan and Shannon, if I pronounced that right. Yes, this is one of the news, that the International Space Station will plunge into the sea in 2031. That's one way to put it. Or the other way, less interesting way, is that by 2031, right now, the International Space Station is said to be decommissioned. So it will plunge into the ocean. Or maybe there is one more thing which we can think of, that if Starship becomes operational, which will by that time obviously, then Starship can even bring back certain modules in its payload bay, which is like the biggest one till now, and it can bring back some of the payloads, the modules basically on the station. And if it can, it would be great, because this is an engineering marvel. Obviously it would be a great thing to study, how those modules, after being so many years in space, how they have reacted or turned in. So right now it's to 2031, but let me just tell you that in 2020 also, people were telling that it was supposed to be decommissioned, but that did not happen. It got a 10-year extension. Don't know, because Chinese already have their space station. If you don't know, yes, Chinese have their space station now, along with the International Space Station, that is known as Tiangong Space Station, or you can say CSS, Chinese Space. So and US and China, it's like space war, space race going on in there. So if US don't have any sort of station facility, whether maybe in lunar orbit or just near Earth, we'll have to wait and see what will happen. And maybe just when it will decommission, it will be taken over by private partners. We just don't know what will happen. We'll have to wait and see. Please show to us the schedule of Astra. What about the technical analysis of it? Actually, I have talked a lot about that. Even the rocket part as well as the payload part, I have talked a lot. So if you want to know about it, you can just rewind the stream it. You would have all the technical knowledge. So let me just quickly recap also that the Astra rocket is a 2-stage rocket. The first stage is opened here only. There you go. The first stage is powered by these 5 Delphin engines. These are the electric pump engines, electric pump fed engines, and running on RP1 and LOX as its fuel. So those are the cryogenic fuels, and these engines are Delphin engines running on electric pump fed. Now the second stage, which you can see up here, is is a pressure fed engine, and it's just a one engine. It's known as ether engine, as they say. So they don't have any turbo pump on that, just a pressure tanks which is pressurized, and then the valves are opened, fuel mix with the igniter, and then it comes to life. So the simple design up there, because they wanted to keep it that way, so that whatever they weight they will say on the upper stage, they can have that on the payload capacity. So yes, so this is the technical information you want to have. Too bad not a clear day. Visual on clear day is a few 100 miles. Okay. I hope we get to see the launch at least. If the launch does not happen today, we have a launch window tomorrow also, and right now we are in the business end of the launch window. So if it does not launch now, it would be postponed to tomorrow. Canaveral has just uploaded a video. Okay, Aviator, if you can just tag me on Twitter of that video. On that video, we can all see 1970 Starship. Oh, I about this thing is real or what? To get the KSP treatment after this. I don't know whether it's a real or what. What is it? It's look like a Saturn V stage. Is it even real? I don't know. Guys, do you know this thing? Do you have any idea about this thing on your screen? I'm seeing it for the first time. Germany flew a VTOL past Mach 1 in 1964, and it was theoretically Mach 2 capable. Is absolutely insane. Whoa, I did not know about this. BJ-101 aircraft, EOL aircraft. That is so cool. And that was done in 1964. How cool is that? There are so many parts the history that during that space race or world war had made some great progress in technology. At least I would say that. Not know about this too. Obviously, booster 4. You just wait for some more time, 2 more minutes, and we should be having the webcast starting. So wait for some. Nope. Want to replace the worm logo. I am more in. Oh, Winter Olympics have started. But I think many countries are boycotting also. I don't know, but I think so. And if you don't know, guys, this Blue Shift Aerospace is also one of those small sat startup, and they are doing great work, because the fuel which they have is they are using basically a biofuel which is environmental friendly. They call themselves the Uber to space, and they will be launching from May in USA. They already had a launch of their Stardust rocket in 2021, Jan 2021, and they were supposed to have their Starless rocket launch in 2022, but now they have made a significant progress. But now they are aiming at 2023 Q1 launch for their Starless rogue, the next iteration. Just wait for one more minute. Hopefully we should be having the stream. See if Twitter is undead, still alive. Yes, it is, obviously. I don't I think in Russia nobody uses Twitter, I guess. And Twitter is a place where opinionated people lives, as well as many good people also live. When it comes to space community, you should be able to get along with many good people. And I would say rather, if you want to meet to any people interested in space and a community regarding space and rockets, you should have a Twitter account. Okay. Wait a sec. They are live now. Guys, if you have not liked this stream, please do give it a like. On this channel we do this live streams where we make you understand everything that you need to know about the launch. So please hit that like button and subscribe, and even become a member. It really helps the channel, so it would be great if you can do that. There are new what? A new launch. I'm waiting for them to roll. Twitter is heavily censored in Russia. Maybe that's the problem. Because if censorship comes in, then okay, trampoline is working. I know what that reference though. I'm not a real person, and I can't. I don't know the situation about Twitter is this bad in Russia about that. Because yes, and I haven't seen many Russian people using. There is very handful of people from Russia which I have found on Twitter regarding space and rockets, whatnot. So yes, that is the thing. Still waiting, guys. And don't worry, whenever we'll have the webcast, I'll switch over to that. So just don't worry about it. If you want, guys, please do follow me on Twitter as well, or you can just become a member of this channel. It would be great. Can do that. Really helps me. So we do have this, and let me just, people who were saying the weather, just see this, guys. Thank you so much all for tuning in. Really appreciate you guys. The launch commit criteria. Can you see anything red in here? This is a criteria for Astra. The range weather is go, user weather is go, and the lightning phase. Everything is green. Surface electric fields, lightning, attached, full cloud, closure winds. Everything is good right now. So we are good to go with the launch today, and we are just waiting for the webcast to begin. We are T minus 40 minutes until the launch happen. Everything is looking good. The censorship on Twitter. Okay, you are not talking about just the Russia, but okay, I don't know about that. But whatever censorship we're talking about, there is nothing of that sort in space community. So you are just into that, it would be great for you to have be on Twitter. Hi to all. Hi everyone. Right now the weather is go for the launch, and then they have, okay, they have again changed the webcast time by 10 minutes. Wow. Are we even have, can see everything is green? I don't know what this gray thing means. What does it say? This tribo electrification, not well, it's not green, but have some steam. Okay, wait a second. I'll just switch over to that stream. Don't worry, I found one. Wait a second.
That mission placed a dummy payload into orbit. That followed 3 previous orbital launch attempts by Astra in 2020 and also earlier in 2021. All those flew from Alaska, and functioning satellites on board. However, the mission is still classified as a demonstration flight by Astra and NASA. It's officially known as the VCLS Demo 2A mission, the Venture Class Launch Services Demonstration 2A by NASA, which is the customer for today's flight.
Okay, so we have some live views, although we can't see much from here, but at least something is better than nothing. So that's that. And shout out to Spaceflight Now for providing this live stream. And
looking live at a view of Space Launch Complex 46 at Cape Canaveral Space Force Station. It's a gray afternoon, breezy conditions here on the Space Coast of Florida. However, all weather rules are currently observed green. So weather is not, at this moment, an issue. However, there is cloud cover overhead, and the weather officer will continue monitoring the conditions throughout the remainder of the countdown to ensure that clouds and winds are within limits for launch today. T-minus 36 minutes and 45 seconds.
so just at the center of this,
at the center of your view,
rocket,
you can see the very top of the payload fairing of the 43-foot tall Astra Rocket 3.3 or LV0008 launch vehicle. It's just peeking above the tree line from our vantage point, 1.7 miles from the pad. Again, this is quite a small rocket by launch vehicle standards, 43 feet tall, 52 inches in diameter. So you're not seeing a great view because of the rocket's size. However, once liftoff occurs, we do expect to be able to track the rocket as it climbs off the pad and heads northeast from Cape Canaveral Space Force Station out over the Atlantic Ocean. There are clouds overhead, so the rocket will disappear from view at some point in the first minute or so of flight, by my estimation, as it heads downrange.
And we also have an onboard camera, so hopefully we would switch over to that, so there won't be any problem with video feed as such. I hope that is the case, because in previous mission we did have the onboard cameras. So this is the live view of the SLC-46, and you can just see the top of the fairing basically here, this small thing. Yeah. Much better visible. Hello, hello, escape in Florida, right? Yep, it is. You can actually see just the top of the fairing right now on this camera. We still have like the 10 minutes or 5 minutes or so remaining until the official webcast begins, so we can have a look at this. By then, just the view of the station, launch site. You can see the weather. Right now everything is green for the launch, but still monitoring those cumulus cloud conditions, which you can see it's like slightly cloudy out there. So yes, is it a go or what? Yes, we are T-minus 34 minutes or so until liftoff. We are green for the launch. Everything is looking good, and in just 5 minutes or so you should official webcast too. And guys, thank you all for joining in. I really appreciate this thing. T-minus 34 minutes, Daniel, until the launch. Just wait for it. You should be able to see. Guys, just give this stream a like if you love what you see. If you like my commentary, just give this stream a like and subscribe to this channel. It would be great, as on this channel we do a lot of hard work, and you know, those launches which are not available anywhere, but you will find those launches here. I'm talking about the Chinese one. Very hard for me to find the Chinese launches, but I try my best to do that, and subscribers of this channel know that. If you are into rocket launches and science in general and rocket science in general, you can this channel try. And if you want to support me, you can do that by becoming a member or a Patreon.
T-minus 33 minutes and counting. Again, you're looking at a live view of Space Launch Complex 46 at Cape Canaveral Space Force Station, where Astra's Rocket 3.3 launch vehicle is standing 43 feet tall. It's the smallest orbital class rocket to ever fly from Cape Canaveral, Florida, just peeking above the tree line in this view. So you can only see the upper part of the payload fairing, the NASA meatball emblazoned on that payload shroud, containing 4 CubeSats inside, sponsored by NASA. Astra's Rocket 3.3 again stands 43 feet or 13.1 meters tall. It's 52 inches or 1.3 meters in diameter. Again, it's the smallest orbital class rocket to ever fly from Cape Canaveral, and it's one of the smallest in the world, designed to carry small satellites of up to 50 kilograms or 110 pounds into low Earth orbit. 5 Delphin first stage engines are mounted at the base of the rocket, and 1 Ether engine powers the second stage. Those engines all burn a mixture of kerosene and liquid oxygen propellants, and those 5 Delphin first stage engines will be generating 32,500 pounds of total thrust during their nearly 3-minute burn to begin today's mission. That's around 50 times lower thrust than SpaceX's Falcon 9 rocket. Now, T-minus 31 minutes and 20 seconds. Again, you're looking back live at Space Launch Complex 46 at Cape Canaveral Space Force Station, where Astra's Rocket 3.3 or LV0008 launch vehicle is standing ready for launch at 3:30 p.m. Eastern Standard Time or 2030 UTC.
Okay, so still waiting on for the webcast. Hopefully it won't slip further now. We are still go for the launch, so I hope everything we will see the webcast soon. And I can see many Russians in the chat, and obviously Russians on a lot of stocks in Astra. I didn't know that, but can buy US stocks in Russia. First of all, that is a surprise for me. Nevertheless, rocket is on the pad, weather is go, and we are T-minus 30 minutes until this small cute little thing goes off into the sky and beyond and deploys 4 payloads its orbit. Space Flight Simulator, Sebastian. Yes, if you have played KSP, then that would be also great. Space Flight Simulator is fun. Kerbal Space Program is double fun.
Now T-minus 29 minutes and 20 seconds. Some first hints of vapors are visible now, venting away from Astra's Rocket 3.3 launch vehicle out on pad 46 at Cape Canaveral Space Force Station. This indicates that propellants are now flowing into the 2-stage rocket. These vapors are actually gaseous oxygen vapors venting from the launch vehicle's fueling system as propellants are loaded into the rocket. That propellant loading process was expected to get underway in the final hour of the countdown, around roughly 60 minutes before liftoff or so. So that fueling process should be well underway at this point. And we're seeing indications of that from this venting.
Yes, I knew N1. That is not a thing. We are Russian speakers, not necessarily ethnic Russians. Very true. But the thing was that I did not know whether it was even allowed to buy US stocks in Russia. You know, geographic reasons, political reasons, whatever. Why birds fly there? Can you can you just tell me, can you stop a bird from flying there? Can you tell a bird, please don't go near a rocket or it will fly, or it will just fry you, make you a toast? Can't, right? They are just animals. You can control land animals, but not these flyers, birds. So, and there are many incidents when a rocket launches, that birds are nearby and they die. There have been cases. But whenever a rocket launches, the sound, vibrations, all those things are so huge that any nearby animals or birds, they just go off automatically. Oh, hi Wildflower, how are you? You joined at the right time, T minus 26. Still waiting for the live cast to begin. And again, those towers, those electric towers, they are bigger than the rocket, and they should always be bigger than the rocket. So that whenever a lightning strikes, those towers would be affected and not the rocket. Okay, so I'm well, Wildflower. Where's the rocket? Rocket is just at this middle part. You can just see the fairing right now. This camera is way far. This is just the fairing you can see here. So that is that. The birds are there, obviously. Should I just kill the music or what? I can change the music, but it would. I have other music. But it won't be great if I switch over to that now. We are at 24, and I don't know what has happened to the official cast. Why is it not beginning? We are at 24 minutes. Okay, it has begun. So I'll switch over to that, and you don't need to listen to that music. Wait a sec. There you go. So the official webcast has begun, but still not. How?
We have liftoff. Propulsion continues to be nominal.
RCP chamber pressure looks good. Doubling up. Roger, roll, ELaNa.
Water towers fly!
They go down to nominal.
Body downside of speed off.
Bring in and speed off.
Yikes. You bet. Concur. We don't need any more of these.
There you go.
Hello, everyone, and welcome to this live view of Launch Vehicle 0008 on the pad in Cape Canaveral, Florida, Space Launch Complex 46 at the Cape Canaveral Space Force Station. Right now, we are at T-minus 22 minutes and counting towards Astra's launch attempt for the NASA ELaNa 41 mission with the goal of deploying 4 CubeSat payloads into orbit. We're coming to you live today from both Cape Canaveral and Alameda, California, where Astra's headquarters is. My name is Thomas Burkhart, News Director for NASA Spaceflight, and I'm joined by Carolina Grossman, the Director of Product Management at Astra. Carolina, thank you so much for joining me.
Thank you, Thomas. Glad to be here.
Absolutely. Really quick, we want to get into a status update on today's countdown. Like you saw, we're at just under 22 minutes and counting. So, Carolina, can you give us a status update?
Sure. Thank you for your patience if you've been waiting for us to begin the stream. The team is actively troubleshooting an issue with an asset on the range. However, we are proceeding and hoping that the issue will be resolved in time for our T0 time in just about 20 minutes. The team has loaded propellant onto the vehicle and completed all of the checks that need to happen, so everything appears nominal. We're also keeping an eye on the weather. A cold front has moved through the area last night and into this morning, so we are keeping an eye on those surface level winds. But pending the range asset, we believe everything else is looking good for our upcoming T0 time.
That's great.
We will continue to monitor the status of that range issue and the weather as well and keep you updated as we hear more. But right now, the clocks are proceeding as we're coming up on 20 minutes and counting. Once again, Astra and NASA Spaceflight are partnering to produce this live stream, so thank you to Astra for helping cover some expenses involved in making that happen. And while we wait for more word as the countdown proceeds, we're also going to just do a brief overview of today's mission, which is the NASA ELaNa 41 mission. There are 4 CubeSats on board, 3 from different university teams, and 1 from the NASA Johnson Space Center. Carolina, you want to talk a little bit about the orbit that we are targeting today?
Yes, we are heading to an orbit of 500 kilometers and 41 degrees, where we will deploy the 4 payloads from 4 different universities: the University of Alabama Tuscaloosa, the University of California at Berkeley, New Mexico State University, and then NASA's Johnson Space Center has provided that 4th CubeSat on our mission. They're very exciting technology demonstrations and scientific investigations aboard today's mission.
Excellent. And of course, that map also points out the new launch site for Astra, the first time launching from the Space Coast here in Florida, Cape Canaveral Space Force Station's Launch Complex 46. And Carolina, this is another milestone for Astra as well, yeah?
Yes, this will be our first time launching out of Cape Canaveral, which is very exciting. We are very thankful to our partners at NASA and Space Force, in particular the Space Launch Delta 45 and Space Florida, who have been absolutely wonderful to work with. One of the advantages of Astra's launch system is that much of the system is very easy to transport. So everything you see actually fits in shipping containers, and so we can really launch with just a pad and a fence and some internet. So we have been very grateful for the work from our partners in getting our pad set up very quickly over the last few months to make today's mission possible.
Excellent. This is also, of course, the first mission with payloads on board an Astra rocket that will be deployed into orbit as actual satellites. The ELaNa 41 mission is part of the Educational Launch of Nanosatellites program for NASA. This mission is also being referred to as the Venture Class Launch Services Demonstration 2 mission, which is the class of launch services NASA uses for these dedicated small satellites. And so that's another milestone for Astra as well. And of course, the first launch of 2022 after the first successful flight late last year on the LV0007 flight out of Kodiak, Alaska.
Yes, that's all correct, Thomas. We are very excited about today. These venture class launch missions help NASA support the development and demonstration of new commercial launch vehicles like Astra's rocket, and these small satellites have a higher risk tolerance, so we can demonstrate the system and mitigate risks and provide access for future small spacecraft and missions. And these CubeSats have a large role in exploration, technology demonstration, and investigations at NASA because they provide a low-cost platform for these missions.
Very cool indeed. So right now,
as we come up on about T-minus 17 minutes here, Carolina, can you talk us through what's going on in the countdown now and the big milestone that we're about to hit in about a minute or 2 minutes?
Sure. So we are just about to enter our terminal count, which is the final sort of 15-minute point where we complete the final preparations for launch. Before that, we'll see a test of our water system, so that will kind of be our signal, and we'll wait for the go-ahead from the range issue that has hopefully been resolved.
Range is always a problem, sometimes a problem, right?
And on that point, as we can actually hear the teams going through the countdown at this point, coming up on that terminal count milestone. So let's go ahead and listen into the countdown net.
So we are T minus 16 minutes. Everything is green except the range right now. And you can see the control office, and with those googly eyes, yes, that's a sign of Astra's control center. And other than the range, everything is green. So, and we are hoping that the range will also become green as we move on to the launch. So this rocket which you are seeing in the pad is a two-stage rocket having RP1 and LOX as its fuel in both the stages, upper and the below. The difference between the upper and the below stage is that the bottom first stage is powered by electric pump-fed Delphine engines, 5 of them, and the upper stage is powered by a pressure-fed engine that is named as Ether. So they have tried to make simpler engine for the upper stage for weight reasons, and today they are launching 4 payloads, 3 from universities, 1 from NASA, and one of the payload is very cool because that would be, they are deploying a drag sail basically on a CubeSat to reduce the deorbit time from 5 years to 3 months. The other cool mission is from actually all the satellites going to this for this mission are cool. The other one is the quantum gyroscope. You rather than having a hardware or gyroscope as the sensor on the CubeSat, they are making a quantum gyroscope on the atomic level. How cool is that? The other one is their first ever neutron detector satellite being launched in this mission. How cool is that? And obviously NASA has its own prototype of certain things. So these are the 4 satellites being launched today. Everything is looking good except the range, and hopefully that would clear up. And if you are just joining in and you don't know what is this whitish thing on the rocket, that is nothing but the cryogenic fuels, the liquid oxygen that is there. And I have a question for you guys. Why do you think that the RP1 is kept below and the liquid oxygen is kept above the rocket? And why not the other way around? There's a scientific reason behind that. Think about it. But okay, let me just give you the answer. Okay, we are at T minus 15 and holding.
Hi, everyone. If you're looking, we've held the countdown at T minus 15 minutes, and we'll give you an update as soon as we have one.
Okay, that's not a good thing. Hold. Just update it. I think that's the hold because of the range. Guys, why do we have such range issues? There was one SpaceX launch recently cancelled because of the range. Wayward cruise ship was there. I don't know what is happening with the range.
Astra flight on countdown based on updates from the rock. Astra is just going to finish running its steps from step 122 to 140 and then stop at terminal count entry.
Yes, Richard, you can kind of say it's a baby rocket because it can fit in a shipping
Step
container
122 Tango, can you please reactivate machine AV1 power ESC?
of the truck. So that is a thing. So right now we are on a hold, and hopefully it's because of the range and not a technical issue. We'll have to wait and see. And guys, when it's a hold at T minus 15, that means they have not moved on to the terminal countdown yet. So till T minus 15 minutes they can recycle, and after T minus 15 minutes it would be difficult for them.
Tango,
I don't know
toggle on power ESCs.
whether they can recycle after T minus 15, but T minus 15 is considered as their terminal count, and when you get into terminal count, you actually start your checks with the actual systems of the rocket, which are critical for the mission. So since they have not entered the terminal countdown, still the hopes are green right now. hops are green in the sense that we might see a launch. Let's see. I live about 25 miles west of the Cape. Hopefully this one blows up. If this one blows up, then also you won't be able to see it. First of all, the weather, and the second of all, that this is a very small rocket. Now they are venting some of the liquid oxygen. And you don't want a rocket. First of all, guys, this rocket you are seeing in front of your screen is a very crazy rocket. In the sense that once when we saw the first live stream, it went crazy in the X direction rather than the Z direction. So
And
it
at this
did
time,
not
please
went
confirm status of ESC.
to the sky, but to the left hand side, but still recovered. So chances of being this being
Thank you,
blowing up
Tango
into
Garcia.
species are very less. And again, the YouTube is glitching.
And we do have an update for you all. Unfortunately, due to a range asset that has gone out of service today, we are going to stand down from today's launch attempt of the ELaNa 41 mission. Our launch window does extend to tomorrow as well, at the same time, 1 to 4 p.m. Eastern Time. And you can follow us on Twitter at Astra for updates on the latest. Thank you for joining us today, and we're going to give it another try tomorrow.
Absolutely. Again, thank you to Astra for partnering with us on this live stream to help make this happen. We'll be back with more coverage hopefully tomorrow, pending the resolution of that range issue like we said. So we hope you all come back and tune in again tomorrow. And until then, we'll see you then.
No, guys, F's in the chat right now. F's in the chat. F's in the chat. F's in the chat. F's in the chat. Dude, we waited for so long, and finally, what happened? We were, doing things, saying things about the weather and how can we mitigate that, but range is in our hands, man. Because of the range, this happened. This is the second launch which has been cancelled in recent times because of the range. This is next level.
Yikes. You bet. We don't need any more of these.
Wow. Wow. Don't have any words. Waited for so long and finally this happened. And I have Twitter Spaces scheduled for tomorrow. Wow. Have to wrap that up. Standing down from today's launch of NASA's ELaNa 41 mission due to a range asset that went out of service. Okay, so range asset that went out of service. The team is setting up for the next opportunity tomorrow. So this is not because of some wayward ship coming out the ocean, but a range asset, which means their own ship, which they sent out in the ocean for monitoring of the weather or some signal sort of things, did not happen. So I think the range asset is that, because it says asset and not a problem there. Asset is not a problem, right? Asset is something which you have and which you can get as a it's a thing which helps you. So I think it's their property, Astra's property, thing which was supposed to support the Astra's mission has went some it's had some issues. So I guess that's why we did not had the launch. Big F's in the chat. F's in the chat. Hoping the stocks are still don't think so it will go down, because we still have the launch it did not blow up, so we still have the launch opportunity for tomorrow. But for tomorrow I have the Twitter Spaces scheduled. I have to change the time or something like that. I'll see. So I guess that's it. We waited for a long time, and thank you all for joining in. I really appreciate for you waiting with me, and don't worry, guys. We will be I will be streaming tomorrow also, so do join me on this channel only. You will get a great opportunity to see the launch. We are standing down today due to a range equipment failure causing a critical range detection asset to be unavailable to support our launch. Okay, so this is a thing. So their Astra's property, kind of a thing which was supposed to support the mission, went brr, and it has a range equipment failure causing a critical range detection asset to be unavailable to support our launch. So it's kind of like a ship monitoring the weather, or maybe I think it's a ship which is like a ground station for them during the payload deployment or so. And that had problem. I don't know whether they'll be able to replace that, or I don't know how the things work with the ships. So we'll have to wait and see. Right now, we still have the window opening tomorrow at 10 a.m. Pacific. So okay, I understand now. I understand this thing now. Whatever was going on in the chat now, I understand by the great Musk. Thank you all for joining in, guys. I really hope that you all enjoyed my live stream, and don't worry, guys. I'll try my best to be available tomorrow also. I will not try my best. I will be available tomorrow. Okay? So don't worry about that, and it's not a rud. So be happy about it. It's just a scrub, not a rud. So be happy about that, and it's a great excuse for us to uh, meet again. So why not, right? Let me just see if we have anything else. What is this? Okay, those lunar landers. Acceptable, marginal, very good, outstanding. The cost 0.9 billion, 5.9 billion, and billion. So, guys, thank you all for tuning in. I really hope that you enjoyed the live stream. And if you did, please give it a thumbs up, subscribe so that you don't miss out on tomorrow's live stream. I am already scheduling it now. Is the rocket launching? No, Jared, it's not launching because they had an issue with their range asset, which means the ship which was supposed to support the mission had some issues. So, yeah. And if you have anything else you want me to talk about, please tell me. I'm here for you. Okay, I think that's it. I can end the stream now. Thank you all for joining in. No launch, Catherine. Unfortunately, tomorrow we will be having a launch, so do join me tomorrow. And thank you all for tuning in. You guys are great. Until then, this is Pian Shoroila. You just saw Rocket Gyan. Stay safe, stay healthy, and